this lesson is crazy. We're going to start out with an easy problem. And the second problem, I should say no one particular part of the lesson's hard, but it's a lot of stuff to keep track of and remember. We're using all of the stuff that we've been working on for the last month or so. The second problem on here is using everything. So what we're going to do is just get through the lesson. I'm not giving you a practice worksheet today. We'll work on that in class tomorrow. So I really just want you to copy down everything I copy down and just relax, right? And move the quiz to Monday. Quiz on Monday. So, yes. Yes. It's going to be on the quiz. Okay. All right, so what we're doing is solving rational equations. This is different. Now, yesterday we did solve rational equations, but it was a special kind. Everything I'm about to write down, you don't need to copy. I'm just sort of reminding you of some stuff. So if you want to just put your pencils down and just listen, that would probably be good. Yesterday we solved stuff that looked like this. It's a rational equation as well, but it's a certain kind. It's a proportion. A fraction equals a fraction, and we cross-multiplied and we solved. Okay. What's different about today's equations is that they're going to have, it's not one fraction equal to another fraction, it'll be two fractions on one side, right? And it'll be joined with an addition or subtraction. Now, the basic idea behind today's stuff is just like regular fractions that you add or subtract when they have different denominators. So like, if you had 2/3 plus 1/4, you can't add them yet because their bottoms are different, right? You have to get them the same. What's a number that could be the same for 3 and 4? All right, so I'm glad you said that because it's not 1, because I want you to understand something about denominators. We're not factoring and getting smaller. We're taking multiples and getting bigger. So what number do 3 and 4 both go into? 12, right? And that's the small, they actually go into lots of numbers, right? 12, 24, 48. But you want to keep it as small as possible. And in the past, what that's been called, when you've done this before, it's called the least common denominator. Right? The smallest possible number that they go into. Like they both go into 12 and 24 and 48 and a lot of bigger numbers, right? 12 is the smallest one that they both go into. And so what you would do then, once you identified that 12, you would say, all right, what do I have to multiply this 3 by to make it equal to 12? 4, right? And you have to do that to the top and the bottom. So that what you're really multiplying it by is 1, because 4 divided by 4 is 1. So you're not changing the value of the fraction, just its form, just how it looks. And then what would we need to multiply this fraction by? 3. And then what you do after that is when you're multiplying fractions, you go across the top, across the bottom. So you'd have 8/12 plus 3/12. And you would add just the numerators, and that 12 on the bottom would stay the same, right? That's the basic idea behind what we're doing today. The difference is there will be x's. There will be variables in the denominators. And that changes what we have to look for, but it doesn't change the basic concept that we're about to do, all right? So keep this in mind as we're going through with these fractions. So to get started on this problem, the first thing that we want to do is find that least common denominator. So like the 12 was in that little example, we need to figure out what that would be for all 3 of these fractions with their denominators. Have an x and a 3 and a 6. Before I show you the system that we're going to do, what do you feel like a common denominator would be for x and 3 and 6? 6 for the 3 and 6. 6x, okay? 6x, because the common denominator has to have every denominator represented in it. Like everyone has to come to the party, right? They all have to make one big group where every little part of them is in that bigger denominator. And so it's going to be 6x. Now that's pretty easy to see on this problem, but it's not easy to see, for example, when you have a problem like this one that we'll get to in a minute on the back, okay? So what I'm going to show you is a systematic method for doing the LCD. Now while I'm doing that, you might be thinking, why is she making it so hard? This problem is so easy. It's so that you can see the complicated steps with an easy problem. Okay. We already know what we're looking for. We already know it's 6x. But I'm going to show you how to break that down. The first thing you're going to want to do is factor each denominator, okay, whether it's an easy problem like this or a harder problem. So looking at this one, though, so you have 3 denominators. There's only one of these that can actually be factored more. Which one? The 5 over 6, right? Because this denominator here, x, you can't break that down anymore. 3, you can't break that down. But 6, you can break down into 2 times 3. And so then part B says you want to build your LCD by using each of those factors one time. Okay, so here's how I'm going to build my common denominator. It needs to have an x in it. It needs to have a 3. This second denominator has to be represented, and we're going to be multiplying these things together. And then it needs to have a 2 and 3 for that one, but I already have a 3. So I'm not going to write it again. But it does need a 2 because it doesn't have a 2 yet. And when I multiply that, what is that? 6x, which is what we already knew we were going for. Now, it's not the end of the world if you put this 3 in a second time. What happens, though, is it makes your numbers bigger, and it can make your math more complicated when the problem is more difficult. And so you want to avoid that if you can. So there's our LCD. So that's step 1. The second step is to rewrite the fractions. That's the step where you multiply the top and bottom by the same thing. Like in the initial example, it was like times 3 over 3 or 4 over 4. This is that step, but with variables. So here was the original equation. We're trying to get all the denominators to look like this, 6x. So what do I need to multiply this first denominator by? 6, right? The 3 and the 2. It's already got the x, but now it needs the 3 and the 2, which is 6. So top and bottom has to be the same. What is the 3 denominator missing? 2, the 2 and the x, because it already has the 3. So multiply that to the top and bottom. And what is the 6 missing? X. So then once we multiply across the top and bottom, we have this. 6 over 6x. 2x times 1 is 2x. And then 5 times x is 5x. So now we have all the denominators the same. That's fabulous. Now we're going to get rid of them. So we are going to clear denominators. And the reason we can do this is because of the nature of an equation. The left side equals the right side. It's imbalance. And so if we get rid of the denominators and we can then just do the math on the numerators. Yeah. And then from here we just solve. Sometimes depending on so this is an easy solving. It's very straightforward. Sometimes we'll have to do more math after this, like factoring. We'll do that on the next problem. But for here, this is pretty easy. What am I going to do? Subtract 2x. And then divide by 3. And x equals 2, maybe, perhaps, it's possible. Yes, because we have to be sure that that solution doesn't do what to any of the denominators? Mess it up. How does it mess it up? Make it a 0. Okay? So you have to figure out what your extraneous, what your excluded values are. So that's this step right here. Check for extraneous solutions. Going back to the original equation, there's really only one denominator I'm concerned about here. Which one? X. We talked about how if there's just a constant under there, it's like the 6, it can never be 0. It will always be what? 6, right? It will always be 6 right here. It could never, no matter what I plug in for x, that will always be 6, can never be 0. So I don't have to worry about that. What will this one always be? 3. This one with the x could be lots of stuff, right? That's why it's called a variable, because it could vary. What's the one number that would make it 0 right here? If I put in 1, it would be 1. That would be all right. What? I think I hear. It's 0. 0. Right? What's the one number that you put in for x right there would be 0. 0. Right? So when we go to do our work, we have to be mindful of the excluded values. So the excluded value is that x cannot equal 0. Did x equal 0? No. So we're good. All right. That's a lot of different things to remember for one problem, right? Yeah. So this next one that's on the back is going to have some factors involved. Okay. Does anybody need this one up anymore? And our goal for today is just to get through the next problem, just copying it all down. And I have a practice sheet of problems that we can work on in class tomorrow. Okay, so here we go. Just tell me, what is the first step? What do we write in the arrow on the other side? Find the least common denominator. Thank you. So find the LCD. Okay, and read to me the A step for that. Okay, factor each denominator. So we've got p squared plus p. 2 of those denominators are that. And then we have the p plus 1. So notice, even just this step alone, you have to remember all your factoring methods that we've learned, that we've been working on for the past month or so. We have GCF, difference of squares, grouping, and AC method, right? What do you think applies right here for p squared plus p? People always guess that first because they see the squared, right? But it's not a difference because, yes, greatest common factor. It's not a difference because it's not subtracting, so it's GCF. So what common factor do p squared and p? They have p, right? So you're going to divide that out of both of them, and that leaves you p times p plus 1. So that's the first denominator factor. The second denominator is the same, so it factors the same, p times p plus 1. P times p plus 1. And then what's up with that last denominator? I'm trying to factor it. Can't, right? Because it's not anything being, you can't, there's nothing that applies there, so it just stays p plus 1. All right. Clint, read part B for me out loud, please, for everyone. All right, thank you. So here's where we build the denominator. So looking at that first denominator, it's got 2 factors. It has the p and the p plus 1. So the p needs to be there. We need We don't need 2p, we need AP. And then the p plus 1 needs to be in there. And then when we go to look at that second denominator, we don't have to repeat anything unless it's repeated up here. So I need 1p, but I already have it. I need a p plus 1, but I already have it. Okay. You don't want to write those more times than you need because it'll get real complicated real fast. And then the last denominator, I need a p plus 1, but guess what? I already have a p plus 1. Okay, so we're set up with our denominator. Talia, what's the next step called in the arrow? Okay, thank you. So that's what we're going to do here. Rewrite the fractions. Mario, read this for us, please. That's a step for that. All right, thank you. You're going to multiply the tops and bottoms by whatever's missing from the LCD. So I'm going to rewrite the original equation. I'm going to leave the bottoms in the factored form because we did that work, so I'm going to roll with it. So leave this like this. So look at that first denominator. So that step that we just read out loud, multiplied by the missing LCD factors. What is this denominator missing compared to the LCD? Nothing. It's not missing anything. So you know what? Just leave it. That's good. What is this denominator missing compared to the common? Nothing. What is this denominator missing? A p. So you need to multiply the top and bottom by that missing factor. Bless you. But once you put that there, it's times everything in the numerator and denominator. So you have to recognize that that's going to turn into a distributive property. Because it's all of this times that p, not just one of it. And so what is the, Jackson, read the next arrow for us from the front of your notes, please. Bless you. Okay, clear the denominators. Thank you. We're going to distribute it in just a second. In fact, that's this B step right here. Bless you. So step A says remove the denominators, okay? So you're really just going to get rid of those. And then like Jacob said, and I think this is what you're asking me, part B says to distribute in the numerators, right? The first two numerators didn't have to change at all, so I just can write those down. P plus 5, and then equals 1. But what am I distributing in this second one? The p, right? P squared minus 6p, that's right. But notice I still have that minus in there from the original problem. So I have to deal with that here in a second too. Hannah, what is the last step called? What do we write in the arrow on the front? Solve, right? So that's what we can do now. Now that the denominators are gone, we can start solving. Bless you. So what do you think I need to do first? Distribute the negative, right? So now it just becomes regular algebra. Because I knew I had that negative out front that I was going to have to take care of. If I had dropped the parentheses right here, I might have written this. Because it kind of feels like that, right? This minus goes here, and then that minus goes there. But it's really, we have that negative. So now here's what's up with this. And we talked about, what I'm about to tell you, we talked a little bit about Friday when we were doing excluded values. You are going to have to factor, set your factors equal to 0, and solve. We talked about the zero product property on Friday. But if you remember, before you can do all that, so here's your clue, you're going to have to do that. Because we didn't have to do this on the first problem. When you have a squared term and other terms to the 1, that's a quadratic. You have to get it in standard form. So you need it in standard form before you can factor and solve. Well, standard form means a squared plus bx plus c equals 0. You have to get everything on one side before you can factor. I got stuff on both sides. Do you want to move the stuff on the left over or the stuff on the right over? What would you like? Left? Okay. So to move all that stuff on the left over, you just do the opposite of whatever's going on right now. So it's minus p minus 5 to both sides. So this gives me 0, negative p squared. 6p and negative p is a 5p. And then negative 5 and 1 is negative 4. What don't we like about that, the way it is? The negative out front. How do we take care of that? What's our little math trick when we want to change signs? Flip everything. Basically, we are dividing or multiplying both sides by negative 1. So you're flipping all the signs. P squared minus 5p plus 4. I know. We're using all of our math skills on these problems. I changed the sign right here. I flipped all the signs, divided by negative 1. Okay, do you remember I said at the beginning of the lesson, just write everything down. And tomorrow we're practicing more. Just listen and absorb and write it down. Carmen, what was your question? Because I don't want this to be negative because I'm about to factor. So I changed the signs. Daniel, did you have a question? No? Okay. So now, 6 years later that we're here, we're not even solved yet. 3 terms, it's a quadratic cross method. So what multiplies to 4 and adds to negative 5? Negative 4, negative 1. This is shortcut because the a value is 1, so we don't have to do grouping if we don't want to, and we don't. And then in order to solve for each of those p's, so we have something times something equals 0. That means separately, one or the other must equal 0, so we set them equal to 0, and then we solve. Maybe. What do we have to make sure that they don't do? Make any of the denominators 0. So this is the last step of the problem, and you will survive. So we have to go back to the original equation. Look at those factored forms and figure out what would make those equal to 0. This is from Friday's lesson. So we have p times p plus 1. So I'm checking for extraneous or excluded values now. Break them up. These are my excluded values. P cannot be 0. P cannot be negative 1. Did I get either of those values? No. So these are good. Congratulations. We'll do practice problems together tomorrow, okay?